All right, let's dive into something truly mind-bending. We're about to go on a journey that spans not just trillions, but googles of years. We're going from the very first spark of our universe to its cold, dark end, and, just maybe, to what comes after.
So let's kick things off with a question that sounds more like philosophy than physics, right? What if the end of everything isn't an end at all? What if it's more like hitting a cosmic reset button? Could the death of our entire universe be the very thing that triggers the birth of a brand new one?
To even start to figure out how a universe could be reborn, we have to go back to the very beginning and look at its books. And it turns out the cosmic balance sheet has a very surprising bottom line.
There's this wild idea called the zero-energy universe hypothesis, and it suggests that our entire vast cosmos, with all its trillions of stars and galaxies, mathematically adds up to zero, nothing. The positive energy of all this stuff is perfectly, and I mean perfectly, canceled out by the negative energy of the gravity holding it all together.
So if you look at this cosmic balance sheet, it's pretty wild. On one side of the ledger, you've got all the positive energy, matter, radiation, dark energy, you name it. But on the other side, you have this immense negative debt from gravity. And when you add it all up, you get a big fat zero. And this is the key takeaway. A universe that costs nothing to make can, theoretically, just pop into existence from nothing without breaking any of physics' most fundamental laws.
But here's the kicker. This nothing isn't actually empty. In quantum mechanics, what we call the quantum vacuum is, it's buzzing with something called zero-point energy. You should think of it as this sea of potential, where tiny virtual particles are constantly flickering into and out of existence. This isn't a void, it's the raw material for reality itself.
Okay, so if the universe is a zero-sum game that just emerged from this quantum potential, what happens to all the complex things that form inside it? The stars, planets, us? Well, all that complexity eventually gets processed by the universe's ultimate engines of change, black holes.
You see, when anything falls into a black hole, it gets incredibly simplified. There's this amazing idea called the no-hair theorem. It says that all the complex details, whether it was a star or a spaceship or a library of books, all that information, all that hair gets stripped away. The black hole only cares about three things: its mass, its charge, and its spin. Everything else is basically wiped clean. But here's the thing. Black holes don't just hoard everything forever. The great Stephen Hawking figured out that because of those quantum fluctuations we were just talking about, right at their edge, they slowly leak energy back out into space. We call it Hawking radiation. And it's this incredibly, impossibly slow process that causes them to evaporate over trillions upon trillions of years, returning everything they ever ate back to the universe as simple, featureless heat.
Now, this whole idea kicked off a huge debate. Is the information about what fell in completely destroyed, or is it just hidden? The modern view is that it's scrambled. The information technically gets out in the Hawking radiation, but it's so chaotically mixed up that it's completely impossible to reconstruct. Think of it like this. If you toss a notebook into a raging fire, the information is still technically there in the atoms of smoke and ash, but for all practical purposes, it is obliterated. Black holes are the universe's ultimate information shredders.
Okay, so let's jump forward. I mean, way forward into the far, far, far future. After the last black holes have done their job, the universe enters its final act, a slow, quiet fade into a cold, dark, and utterly empty state.
The timescales here are they're staggering. It's hard to even wrap your head around them. After 10 trillion years, the very last stars will flicker out. 100 trillion years from now, the galaxies themselves will have dissolved into nothing. And then, finally, after a Google years, that's a 1 with 100 zeros after it, the very last, most massive black hole will finally evaporate in one last flash of light, leaving behind an almost perfect void.
But for a true, total reset, one last thing has to happen. Even the fundamental building blocks of matter, things like protons, they have to decay. Our best theories suggest this takes at least 10 to the power of 33 years. It's an impossibly long time, but it's the absolute final step needed to erase all mass from the universe.
And this leads to a truly bizarre final state. Once all the mass is gone, the universe is just filled with massless particles, like photons, all zipping around at the speed of light. And here is the absolutely wild part. According to Einstein's relativity, for a photon traveling at light speed, time stands still and distance doesn't exist. With nothing left to measure with, no clocks and no rulers, the universe literally forgets how big it is or how old it is. And that strange, scaleless state, that is the absolute key. It's where the end of one universe creates the perfect starting conditions for the next. This is the core of an incredible idea from the brilliant physicist Sir Roger Penrose.
So here's how it works, and it's so elegant. First, all mass fades away. Then, because there's no mass, the universe loses all sense of scale. This creates a state where only the shape of space-time matters, not its size. And in that bizarre state, a vast, cold, empty universe is mathematically identical to a tiny, hot, dense one. The cold, empty future can simply be rescaled to become the hot, dense Big Bang of a brand new cosmic age.
As Penrose himself puts it, the end isn't just like the beginning. He says the extreme remote future of one cosmic aeon perfectly maps onto and actually becomes the Big Bang of the next. It's not a metaphor. It's a seamless, beautiful, and frankly shocking transition.
So, this is an absolutely incredible theory, right? But is it just a neat idea on a blackboard, a mathematical curiosity, or could we actually see evidence of a universe that existed before our own?
Amazingly, Penrose's theory says yes, we can. The final flash from a supermassive black hole in the previous universe, it would get squeezed down and pour through our Big Bang as a concentrated blast of energy. And this would leave a scar, a hotspot, on the afterglow of our own creation, the cosmic microwave background. Penrose calls these Hawking points.
Now, Penrose and his team claim they've actually found these points, these unusual hotspots in the data from our sky. However, and this is a big however, the wider scientific community is pretty skeptical. They argue these spots aren't statistically significant, that they could just be random fluctuations predicted by more standard models. The debate is very much ongoing, but it's a truly tantalizing hint that we might be looking at the relics of a former cosmos. And so that leaves us with this final, truly profound question. We look up at the night sky, we look at the faint glow left over from our own Big Bang, and we have to wonder, are we just seeing the beginning of our own story? Or are we also seeing the ghostly echoes of a universe that lived, died, and was reborn long before ours ever began?